Hello, welcome to Module 3. We are going to be looking at polynomial functions. Remember, when it comes to Module 3, we looked at roots, factors, and standard form of a polynomial. Okay, remember that. That's so crucial. Okay, you have to be able to write polynomials given factors or zeros, and then also understand the graphs of them. Okay, understand that solutions. When it comes to solutions, it's the same thing as roots, zeros, and the x-intercepts. All right, now with that in mind, let's look back at some things that you might need to know. So I'll go ahead and, here's standard form, here's factored form, here's roots. You got to be able to go back and forth, okay? Know how the graph is connected to this. So here it's like we know that this is a root because it crosses the x-axis. It's an x-intercept. We understand end behavior. For here, this is a degree of 4, which means like a touchdown. So as x is going to the right, it's going up. That's what this end behavior is communicating. And as x is going to the left, it is also going up. Okay, the y-intercept is where it crosses the y-axis. And then we have maximum, minimum points. That's just where we have those transitions, where it goes from decreasing to increasing, decreasing to increasing. Okay? All right. So here, it says, what is, and then it gives you a gazillion things. Now notice that there's a plus sign right in the middle. So all we're going to do is multiply one side, FOIL this side, and then FOIL this side, and then combine all the like terms. Okay? Oops. So let's go ahead and do that. So since the first one is x times x, I know that that's going to be x squared, and then this and this will subtract, and I'll get minus 4x. And then they will multiply to give me negative 32. Okay, that's the one side. Now I know I have to add those things together, so here's a big fat plus sign. And then the next one over here I'm going to distribute, and so I get x squared, and then those will subtract to get positive 6x, and then they'll multiply to get negative 27. Okay, so now I'm just going to combine the like terms. I see that we have 2x squared, so that's going to be 2x squared. And then here, this is a negative 4 and a positive 6. So that'll be a positive 2x. And then right here, the 32 and the 27, those will be added together, but they'll be negative. So that'll be, 59. Okay, so that's the sum of that. Okay, next, so down here, it's talking about Europeans' shoe sizes. So here's the American or U.S. shoe size, and then the European shoe size. So what we're trying to see here, I think, is they want to see as you increase in size, how is the European sizes increasing? Okay, so here this is 1 to 3. So what's the difference from here to here? Yeah, it's going up by 2, and then it's pretty consistent. It's going up by 2. Okay, and then on this side, we see from here to here, it's going up by 2 as well. So then we could probably safely assume that this one is going to be 38, and then because that's increasing by 2, and then this one will be 40. So then that leaves A to be 42. So we can find the value of A. We got that. Check. Okay. We could also see that if this was the y-axis or y values and this was the x values, we see that our slope, remember it's the change in y over the change in x. So we see that the change is 2 over 2. So our slope is going to be 2 over 2, which is 1. Okay, so that's good to know. We'll deal with that later because it says write an equation. So we've got the m, and obviously it's going to be linear because it's increasing constantly right here. So we're trying to put it in this form, y equals mx plus b. Well, we got the m, right? How do we figure out the b? Well, the b is the y-intercept. That's where it crosses the y-axis. So that means that your x value is going to be 0. So we want to go back to where this is 0. So as I'm going back, I know that I can go back 2, and this would be 32. And then if I go back 2 more, that'll be 30. Now the problem is that this is not 2 back. So if I was to only go back 1, wouldn't that be 31? So our y-intercept then would be 31. So if the b is 31, then we'd write like this. Y equals 1x, or just x, plus 31. that would be the equation there. Then the next thing, it says to graph this function. This is a linear function. I could tell because it has a degree of 1. It's in this format of y equals mx plus b. So I clearly see that my b is -1, and then the slope is going to be 4 over 1. So I'm going to draw my coordinate plane. I begin with the b. Don't forget that. So I'm going to go down to the y-axis where it's -1. And then I'm going to use my slope up 4 over 1. So from here I'm going to go up 1, 2, 3, 4, and then over 1. Now whenever we're drawing a line, we only need 2 points, and we certainly got 2 points. So let's go ahead and draw it. So I'll make it red. And about right there. Bam. That's how you would graph that. Alright, the next one is kind of cool if you like math, cool stuff. It says consider the two functions f of x and g of x. So here I believe this is f of, oh yeah, it says f of x. I should just keep reading, right? F of x is represented by the graph below. Bam. Okay, and then g of x, it's giving us the function. So before we start answering these questions, let's see if we can kind of compare apples to apples rather than apples to oranges. Because right now we've got the equation and then we got the graph. So either we make this an equation or we make this a graph. I think this would be easier to make as a graph. So number one, it's a degree of 2, so that means that it's a parabola, right? And now since the a term, the leading coefficient here, is negative, we know that it's going to be flipped upside down. All right, so there's our parabola. And then we know that this constant term right here is where it's going to be crossing the y-axis. So if we were to put these on the same coordinate plane, this would be crossing right there. Okay, now I'm not sure how wide it is. It could be a little bit wider. It could be a little bit scale. Well, actually, hold on. It's a 4, right? So we know that it should probably, well, not probably. It will be a little bit skinnier. Okay, it's going to rise, increase, stretch vertically. So anyways, this is a good rough sketch of what we've got going on. So let's answer some of these questions. It says in the following statement, which of the following statements correctly compares the two functions? So let's read the first one. It says the graph of both functions cross the x-axis at 0. So do they both cross the x-axis right here? That's a big nope. Okay. The graphs of both functions cross the y-axis at 1. Yeah, I think so. So yes. Okay, so this one is definitely true. And it says they both have a minimum value of 1. Well, this one has a maximum. This one has a minimum. So that would be incorrect. So no way. The next one, it says they both have a maximum value of 1. Well, no, again. All right, try the last one here. It says the function f of x has a minimum. So f of x is the black one. F of x has a minimum at 1. And the g of x has a maximum at 1, and that's what we're looking for there. So there's those two answers. Let's continue. This one, it says, what are the roots of the equation? Now, think back. What are roots? What's another word for roots? Well, we've got solutions. We've got zeros. Okay. Is factors roots? Nope. Factors are not roots, but that's how we find the roots. We get it to be in factored form. So that's what I want you guys to do. You're going to use the x, and so factors of 10, that'll give us -3. And so from here, we get an ugly looking, well, it doesn't factor, okay? There are no factors of 10 that would give us -3 because this is a positive 10. So you would have to use the quadratic formula. Okay, next, number 6, it says the function f of x, and it gives us this thing. It says models the height in feet of football x seconds after it's kicked from the ground. So it says graph the function. Okay, I graphed it. So we know that this is going to be a negative parabola. So it starts right here, it goes up to the top there and goes down. It says, what does the origin represent? So what does this part right here on the function represent? So clearly, I mean, that's where they kick the ball, right? All right. Then it says, what's the reasonable domain? Now, in reality, balls, the footballs that are kicked, it doesn't go through the ground like this graph. It won't go below the ground. So I'd say a reasonable domain is from here to here. Okay, and those values, if you were to solve this by factoring out an x and then setting them equal to 0, you'd get those two values. So it says, what is the maximum of the function? And I'll just do this on Desmos because you're going to get something ugly. So I've got it right there. You can check it out. Anyways, the max height of the football. So I already showed you the answer for number 7. Hold on. So it says, determine whether x minus 3 is a factor of this. Now, since it has a degree of 3, we're not going to necessarily be able to use the x, and I'm looking to see if I can factor by grouping, and I don't see that as well. So what we're going to do here is we're going to start using synthetic division. So I put the 2, the -4, the -8, and the 1. And then since the factor is minus 3, x minus 3, we have to take the 0 of that and put that right there. So the 2 gets a free pass, comes straight down, and then I go 3 times 2, which will give me 6. That goes up here. And then combine those, that'll give me positive 2, and then do the whole cycle again. So 3 times 2 is 6. Combine those to get -2, multiply, you get -6. And then here, this is crucial right here. This -5, since it's not 0, that means it's not a factor. Okay. Next, it says identify the zeros of the factored polynomial. So here, since it's already in factored form, we're going to set each of these equal to 0. X equals 0 would be 1, so that's easy. And then when we set this equal to 0, we'd subtract 5. And then this one, we'd be adding 3. So those are the zeros for number 8. Next, it says, let p of x be a polynomial. And then it gives us 4, this, and this as its 4 factors. So it says identify all of the zeros. So let me put this in perspective here. If 4 is a factor, that means it was multiplied by x minus 1, and then it was also multiplied by this, and then it was also multiplied by x squared minus 2. So to find the zeros, we have to set them equal to 0. So 4 equals 0. Okay, that's not going to be a 0. Now, we know that this one right here, when we set this equal to 0, we're going to add 1. So we know that one of our zeros is going to be positive 1. Now this one's tricky because it's kind of like reversed. It's -x, and then we've got a positive 3. So if we set that equal to 0 and start solving, we're going to have -x equals -3, and then that x isn't by itself, so we have to take the opposite, so it's actually going to be positive 3. And then over here, if we set that equal to 0, now I'm going to just kind of get this out of the way here for a sec. If I set this equal to 0, x squared minus 2 equals 0, we're going to add 2 to both sides. Got x squared equals 2, take the square root, and don't forget plus or minus, so we have plus or minus the square root of 2. So all of those zeros, that's what I got. Next one, it says determine by inspection the end behavior of the following. So this one is kind of easy. As we're going to the left, it's going down. And then this one, as we're going to the right, as x approaches positive infinity, we're also going down. Over here, since we don't have the graph, we're going to have to analyze the highest degree and then the leading coefficient. So the highest degree is a 3, so that means it's a disco, okay, increasing from left to right. But then since it's negative, that means it's going to be decreasing from left to right. Okay, so as it's going this way, it'll be going up. So as it's going towards -infinity, it'll be going up. So it's going in the opposite direction of this one. And then as it's going to the right, it's also going down like that one. Okay, next one, it says a soup company wants to introduce a new family-sized soup can that can hold more soup than their traditional can. So they have decided to change the size of their cylinder-shaped can. Cylinder shape. Can their soup? See, I thought can like a. Anyways, there's soup. I can't read. Anyways, the volume of the can. I'm totally confused now. The volume of the can oh my gosh. Whatever. This is the formula. Now that's stuck in my language. Where R is the radius. Okay. And H is the height of the can. It says, will the height and volume change if the soup company changes the length of the radius? So looking at the formula, if the radius changes, it's not going to change the height. It's just making it wider. But instead, that's obviously going to change the volume. The volume will increase. So the height will not change, but the volume will. All right. Here a bank offers the savings account, which pays 3%, and so it gives us this formula here. Don't be intimidated by the word problems. Just look for the formulas, and then it tells you what everything is. The P represents the initial amount. The N represents the number of times per year. The I represents interest rate, and the T represents the number of years. So it says what happens to the other variables when the interest is compounded monthly instead of yearly. Okay, so if it does it yearly, that means it's 1. Okay, if it does it monthly, then that means that this N value will then be 12. So let's just analyze each thing. Okay, so we know that the N value represents the number of times. So will that affect the P, or how will that affect the P? Well, this is going to be something, and it's going to be multiplied. This is going to be higher, so the P is going to be multiplied by a greater amount initially because this is going to be higher. Okay, the I is going to end up being divided by it, and then the T up at the top is going to be multiplied by N. And that's really all we can do there. I mean, well, that's all it's asking. So, done. Number 13, Harold claims that a set of polynomials exhibits closure under division. So let me explain closure real quick. If a rabbit gets with another rabbit, they're going to produce more rabbits. Okay, that's an example of closure. Okay, things produce after their kind. Okay, you're like a rabbit and another rabbit isn't going to produce like a snake. Okay, so here it's saying he's starting off with a polynomial, and then he's got another polynomial, and he's going to divide them, and he's saying that if I was to divide these two, the result is this, and then subtracting these two will result in this. So is he correct regarding both division and subtraction? If you take two polynomials and divide them, will you get a polynomial? If you take two polynomials and subtract them, will you also get a polynomial? So yeah, I mean, these are still polynomials. So since we've got this and we divide it, okay, we still get a polynomial. Okay, and when we subtract it, we still get a polynomial. Okay, so next it says the fundamental theorem of algebra states that every polynomial in one variable, okay, given a degree that's greater than 0, has n complex roots. Now check yours. I don't know if yours has this, but some of them came out with a different like variable right there. So if you have a degree of 2, you're going to have 2 complex roots. Now this is the deal with a complex number, and this is worth explaining. So every number in the world and ever thought of is considered to be complex, like that. Okay, in the form like this, where it's a okay, plus bi. Now since this side has an I, that means that this is the imaginary part, and let me highlight it. Okay, this is the imaginary part, and then the a value, that's the real part. Okay, so every number is technically a complex number. Okay, it's just that, like, if I have a number like say 6, what we can't see is the imaginary part because right now it's plus 0i. 0i means 0 imaginary part. Okay, so this is true in the sense that when I go to solve this, we take the square root, or I'm sorry, we first rewrite the problem in a different color, blue, and we're going to move over the 5. And then take the square root, and we'll get plus or minus square root of 5. Now, is that a complex number? It is. Okay? And since our degree is 2, we also have 2 roots because it's plus or minus. So then this person says that is not true because this has real roots. Well, real numbers are complex. Okay, so that's the issue there. All right. Next, this one I just used the quadratic formula. Do it. Okay, that's the right answer. Now, does this support your claim? This is a degree of 2. Now, this has 2 answers because we have the plus or minus. Okay. All right, number 16, it says to find the remainder. This guy applied the remainder theorem, and what the remainder theorem states is that if you were to take this factor and find it 0, which would be -1, and then substitute it back into this equation, whatever you end up getting would be the remainder. So let's see if this guy did it correctly. So the opposite of this basically is -1. So he substituted it in. -1 cubed would be -1. That looks right. And then -1 squared, which would be +1, times 4 would be 4. -1 times -7 would be +7, and then -10. Okay, so let's see if he then did the math right here. So negative 1, that would be 3, plus 7 would be 10, minus 10 would be 0. So did Sean correctly find the value of the remainder? Yeah. Okay, number 17, it's talking about g of x and f of x. It's shown on the graph. We can see that f is the squiggly guy and g is this one that's decreasing as we go left to right. So it's asking us to plot a point on the graph of g. So again, g is this one that's going across here when x value is 0. So the x is 0 right here, and on g it's right there. Okay, so that'd be point A. And next it says a point on the graph of g. So again, we're going to put a point right here when f of x, the f function, is greater than the g function. So you could actually, there's multiple different answers here, but anywhere where the f function goes above the g function, so right here, f function is above the g function. So you can put it all right here. You could put a point right there, or you could put a point in here somewhere like I did. Any of those would work. Next, it says a point on the graph of f, and f is the squiggly guy, when the f of x is 0. Not when x is 0, but when the y value is 0. So y is 0 right here. So you could put a dot right here. You could put a dot right here. You could put a dot right here. Anywhere that it touches the x-axis. Okay? All right, next it says a $1,000 prize for a lottery is to be divided evenly among the winners. Initially, there are X winners. However, one or more of the winners come forward, causing each winner to receive $50 less. So it says write an equation that represents the situation and can be used to solve for X. Okay, so here we know that $1,000 divided by the number of people will equal the prize money, right? So if we had, let's say, 1,000, we kind of cleaned it up a little bit. We had 1,000 people divided by, I'm sorry, $1,000 divided by however many people is the prize money that each person gets. So now we need to analyze this. That to solve for x, so another person, oops, that should be plus. Whoa. Another person comes, and all of a sudden they get $50 less. So let's see what this pans out to be. This should be a plus right here. So we're going to take these two equations and try to make this happen. Okay, so $1,000, and we've got another person. One more winner comes forward, so another person that we have to divide it by, and then they have $50 less. So looking at this red equation, I know what P equals. P is this guy that's right here, and we have a separate equation, so we're going to treat it like a system, and we're going to substitute in the $1,000. So the 1,000 over x. So 1,000 over x plus 1 equals, and I'm substituting in the 1,000 over x, and then we still have the minus 50. All right, so this is how I would do this. I would treat all of these as a fraction. And I'd say, okay, what's the LCD of each of these fractions combined? And the LCD would be this times this. So I'm going to multiply everything times the LCD. So this basically, so x times x plus 1, and this as x plus 1 times x. Okay, now what we're going to do is just kind of clean up a couple things. So this x plus 1 will divide out with this, and so we're left with 1,000 times x. That's on that side of the equation. Then this x will cancel out with that x, so I'm left with 1,000 times x plus 1. And then over here, I've got to multiply everything. So I'm just going to do this, x squared plus x. That's what the red is right here. So I'm going to distribute the negative 50 to both of those. So that'll be negative 50 x squared. And then I've got negative 50x. Okay? Alright, since I have a degree of 2, I know it's a quadratic, so I'm going to get it all over to one side. I'm going to first get rid of these parentheses. So that'll be 1,000 x plus 1,000. That's a 0. And then I have minus 50x squared minus 50x equals 1,000x. Let's set it equal to 0. Subtract the 1,000x from here. So that basically just cancels that. And so we have it equal to 0. I have the leading term, which is negative 50x squared. And then I have minus 50x and then plus 1,000. All right, now because, oh, come on, 0. Now because these numbers are so big, checking to see if there's a common factor is something that you should totally do here. So see the 1,000? I wonder if 50 goes into 1,000. Yeah, of course it does, right? So if we divide everything by 20, even the 0, because we can't just change. So 20 divided by 0, okay, or 0 divided by 20, excuse me, that's going to be 0. And then this, oh, sorry, not 20, 50, okay. So this would be negative x squared, this would be negative x, and that would be 20. That's where the 20 came from. So that'll be plus 20. All right, so that's a lot workable equation. So, and I'm going to just use the x, but I'm going to factor out a negative first, and then have x squared plus x minus 20. So factors of negative 20, that would give me 1. That'll be 5 and negative 4. So the factors are x plus 5 and x minus 4. Take the opposite for the solutions, or set it equal to 0. This just kind of cancels away. And so then x, the number of people, is either going to be negative 5 or 4. Now you can't have negative 5 people, so the answer's got to be 4. And let's see if that works. If we were to take 1,000 and divide it by 4, that would be 250. And then if we had 1,000 divided by 5, that would be 200. So each of them receive $50 less. So that works.